So today we're going to talk about segment and angle bisectors. And before we get to that, we need to talk about notation for a couple minutes. And there's a word in geometry. It says we need to understand the difference between segments being congruent versus segments having equal measures. And what we say is that segments are congruent and distances are equal. So when we're talking about, segments are congruent. We use this symbol congruent, and it looks like an equals with a squiggly mark above it. That's how we denote congruent. We say segment AB is congruent to segment CD. Segment AB is congruent to segment CD. If we're looking at the distances and actual length of it, we say AB is equal to CD. So over here on the left, on the right side, AB congruent to CD without a line segment, not right. And this as well, not right. Same thing with the angles here, and I think I have a typo down here. Angle of ABC is congruent to angle DEF. But if we have measure in front of that, that's a distance. So this needs to be an equals with no congruent mark on top of that. So measures have the equals, and then not measures have the congruent. So we're just talking straight about an angle, or we're talking about a size, then we have the equals. But now we can get into the bisectors and midpoint. Probably a familiar word to you, but remember also that vocabulary is really important in geometry. Midpoint is a point that's in the middle of the segment. It divides the segment into two congruent segments. And in other words, what we can say then when we look down here at this point, or of this line segment, is that AM, segment AM, is going to be equal to segment MB if we're looking at that from the distance. So in the diagram below, point M is the midpoint. So here's the midpoint. Midpoint, middle of that segment. We know that segment AM is congruent to segment BM. And in geometry, what we do is we use these little marks, these little, what they're called tick marks. On my paper here on the board, it's red. And that indicates, again, what I was saying previously, that AM is equal to MB or BM. Segments with the same amount of tick marks are congruent to each other. So let's look at an example of this one. It says, in the diagram below, M is the midpoint of segment JK. Find the value of X. Well, here we're right in the middle. And if we want to figure out the value of X, that means that X minus 14, that length is equal to the length of 33. Because that point M is right in the middle. And then we solve our equation by adding 14 to both sides. And we get X equals 47. 33 plus 14. A segment bisector. So any segment or line or plane that intersects at its midpoint. So in this particular diagram here, line L, see how it's italics? That's our line L, is bisecting segment AB at point C, which means that point C, this point right there, is the midpoint of segment AB, and also that segment AC is congruent to segment BC. Here is AC, here is BC. And they have the tick marks in there also to indicate the same length. Let's look at an illustration of this as we flip our paper over. So it says in the diagram below, segment DB, so let's fix D here so that we've got a point on there. Segment DB bisects AB. So what that's going to tell us here is that B is our midpoint. It's right there in the middle. And we want to ultimately find the length of BC, but since B is a midpoint, we can take 4x minus 5, and we can set it equal to 11 plus 2x. And solve it the way your Algebra 1 teacher taught you. I'm going to move my letter to the left. Subtract 2x from both sides. And we end up with 2x minus 5 equals 11. We're going to add 5. We need to get the 5 to the other side. Since it's minus 5, we need to undo that subtraction by addition. And we end up with 2x equals 16. And finally, 2 times x. We're going to divide both sides by 2. And we end up with x equals 8. Special type of bisector, and I don't know why I wrote it like this, but special type of bisector called a perpendicular bisector, which it's in bold in the next sentence. Don't ask me why. Can't answer. Perpendicular bisector. It's a line or a segment that intersects the segment at its midpoint and is also perpendicular to that segment. Perpendicular lines are lines that intersect and form right angles. So when I look at this small picture to the right, the first thing that I think when I think perpendicular bisector is that it intersects at a right angle. And we denote a right angle with a box. In this particular diagram, it says, in the diagram to the right, MN and PQ are perpendicular. So again, there's that little box in the corner to indicate that they're perpendicular, which means they're right angles. Another way that we can indicate that something's perpendicular is we can do an upside down capital T. That symbol means perpendicular. To show that two lines are perpendicular, and here it is. MN, segment MN, is perpendicular to segment PQ. By the way, the midpoint, we don't have a name for it, but I just put a small point at that value. There's the midpoint in that one. And let's look at something to illustrate that fact. In the diagram below, CD is a perpendicular bisector. Again, when I see those words, the first thing that I instantly do, and the board's getting a little bit disoriented here, but I try to put in a box. Still disoriented, but you get the idea of that. CD is a perpendicular bisector of AB. If measure of angle COB is 8x plus 50, well, COB is where we just put our right angle box in there. So how much is a right angle? 90 degrees. So we can say 8x plus 50 equals 90. And we can solve this equation. So we're going to move the 50 over to the right side. And we end up with 8x equals 40 we need to undo the multiplication, so it's 8 times x. We're going to divide both sides by 8, and we get x equals 5. But I didn't even read the entire problem. It also says that AO is y minus 7, and BO is 11. And again, we had a perpendicular bisector, which means if the board weren't so disoriented that I could put getting closer, a point right there. And that point that I tried to put at the midpoint, that green value, it's a midpoint. And AO, we said, is y minus 7. And BO, we said, is 11. But since that green point is the midpoint, to find the value of y, we take y minus 7, and we set it equal to 11. We want to figure out what does x equal, what does y equal. So we'll add 7 to both sides, and we end up with y equals 18. As we flip over to the last part, or jump down to the last part, an angle bisector. Well, an angle bisector is a ray. Toby?
Oh, no, it's not instruction, sorry.
An angle bisector is a ray or a segment that divides an angle into two congruent angles. So in the diagram to the right, CD is bisecting angle ACB, which means that angle ACD is congruent to angle BCD. If you're watching the video at home, I would point to those values. ACD is congruent to BCD. In geometry, to indicate that angles are congruent, we mark them with arcs. And I have a small arc in both of those that I hope that you can see. It's a red arc on the top kind of angle and a red arc on the bottom of the angle to indicate that those are congruent, that those angle measurements are the same. So to finish, let's look at an illustration here. It says in the figure below, ray AB is bisecting angle CAD. That means that this angle here is the same as that angle there. So if we want to figure out the value of x, what we need to do is we need to take 33, even though it's degrees, that's okay, and set it equal to 4x plus 1. And then we're going to solve this equation. We're going to subtract 1 from both sides, and we end up with 32 equals 4x. And then we want to undo 4 times x, so we want to divide both sides by 4. So x equals 8.